Welcome to the Deep Dive.
Hey there.
Today, we're plunging into a concept that could really unlock the next phase of Web3 growth, verifiable applications, or vApps.
Yeah, we've been looking at this interesting article, proposed by Layer Zero and Succinct. It really lays out the whole idea.
Right, and our mission here is to, dive deep into that source material, pull out the absolute core insights. We want to help you understand how these vApps are supposed to work.
And why they might be such a crucial step for Web3, to actually break through.
Exactly, and the big role that zero-knowledge technology, ZK Tech, plays in making it all happen.
So let's maybe start with the big question the article poses, something a lot of us think about. Why hasn't Web3 really hit internet scale yet?
It feels like things are improving, doesn't it? Blockchains get faster, cheaper.
Yeah.
We've got roll-ups, modular versus monolithic.
All that stuff, yeah. Important progress.
But the article uses this great analogy. Think back maybe mid-2000s. Early smartphones, first iPhones, BlackBerries. Pretty impressive hardware for the time.
Totally. The hardware was moving forward, but building apps, that was kind of painful.
Yeah, you had to build differently for each one.
Yeah.
Right? Distribution was all over the place.
Updates were a nightmare. There wasn't that single app store model yet, no unified way to build and get your app out there easily. And the user experience,
Yeah.
well, it was clunky. It held back growth.
And the argument is Web3 is sort of stuck in that same phase now. We have the better core tech, the faster chains.
But these structural barriers are still there. They're stopping that explosion to, hundreds of millions of users and that really seamless app development.
What are those specific barriers they point to?
Well, first, for users, it's often just too technical. Managing wallets, understanding different networks, figuring out gas fees.
It's friction, right? People get frustrated and just abandon the process.
Exactly. Apps need to be as easy as Web2 apps. Point blank.
Totally agree. And then for developers, the second barrier.
It's really hard for them to build complex apps that are truly trustless without sneaking in some centralized piece somewhere.
Because building that verifiable logic securely often means getting deep into the weeds of different blockchain rules, maybe even creating custom proof systems.
Yeah, which is incredibly complex. And that leads straight into the third barrier, fragmentation. Just severe fragmentation.
Meaning developers can't easily reuse code.
Pretty much. SDKs are different. ABIs, how data is structured, are different. The proof mechanisms underneath vary wildly from chain to chain. It's a real mess if you want to build something modular that works across systems.
They even mentioned that within, say, ZK EVMs, different versions can have slightly different rules. Makes integrating them tough.
Right. So, okay, those are the problems, the bottlenecks. What's the proposed solution?
This is where vApps come in. The article presents them as this new type of execution environment designed specifically to tackle these barriers.
Using things like verifiable computing, these modular SDKs we mentioned, and critically, zero-knowledge virtual machines, ZKVMs.
All aimed at creating something that actually works well for developers and for the end users.
And the potential upside they sketch out is, well, it's huge. They use another analogy, the global payment system, Visa, MasterCard.
Massive market, right? $20 trillion or something.
Yeah, but built on really old, complex tech. Lots of delays, costs baked in.
So imagine rebuilding that, but on vApps and stablecoins.
That's the picture. Verifiable, trustless, real-time payments across different chains, computation, settlement, all transparently checkable. No intermediaries running on ancient tech. That's the kind of scale they're thinking about.
So the big idea is blending Web3's decentralization and trustlessness with Web2's usability and scale.
Pretty much, using principles like composability, abstraction, modularity as the foundation for vApps.
And the goal of those principles, lowering the entry barriers for users, boosting developer productivity, making the whole system more reliable.
Right. And the article identifies two key technical pillars that make this possible.
Okay, what are they?
First, verifiable computing and the vApp software development kit, the SDK. And second, the zero-knowledge virtual machine, the ZKVM.
All right, let's dig into that first pillar then. Verifiable computing and the vApp SDK. What's the core idea behind verifiable computing here?
At its heart, the goal for vApps is to let developers build apps where you can absolutely guarantee the execution integrity.
Meaning the code ran exactly like it was supposed to, got the right result.
Without having to trust whoever ran the code and without everyone needing to rerun it themselves.
Yeah.
Verifiable computing is the tech that enables that trustless verification.
And that's super important for modular systems, right? Where different parts talk to each other.
Exactly. It lets computation happen off-chain, separate from the final settlement on-chain. You can check the result of some complex off-chain work without the cost of doing it all over again on the blockchain itself.
The article mentions different flavors of this tech, right, with trade-offs.
Yeah, like optimistic rollups. Generally cheaper and faster up front because they assume correctness.
But they have that waiting period, the challenge window, sometimes like 7 days.
Right, before you get true finality. Then you've got ZK rollups. Stronger crypto guarantees from the start, really good for things like cross-chain stuff.
But generating those ZK proofs can be computationally intensive, might limit throughput.
Can do, yeah. And then there are T rollups using trusted execution environments, special hardware.
Those can be fast and cheap, off-chain, good for specific app services.
But you're trusting the hardware, which isn't foolproof, and it's not always easy to publicly audit. So different tools, different strengths.
Okay, so that's the foundation. Now, the vApp SDK, built by Succinct, how did that help developers actually use this stuff?
It's all about developer productivity, making their lives easier. It gives them an integrated environment for both the on-chain and off-chain parts.
And it automates a lot of the hard parts, generating provers, verifiers, setting up infrastructure.
Exactly, that heavy lifting. So developers don't need to be, deep ZK experts or infra gurus. They can focus on their core application logic.
The vApp core, they call it, using familiar languages like Rust with helpers like imports and macros.
Right. And a really key part of the simplification is a standardized verification function. They write it as verify, S-O-S-C.
Don't need to get lost in the letters, but the point is,
it takes the inputs, the old state, the transaction, the proof, and the proposed new state, and lets the chain check cryptographically if it's all correct, using that one standard function.
regardless of whether it is a ZK proof or a TE or optimistic underneath.
Exactly. That's huge for abstraction. And for apps needing cross-chain capabilities, it plugs into Layer 0's messaging protocol.
Through interchain interfaces.
Yeah, which handles secure communication and coordinating transactions between chains synchronous, asynchronous, even atomic execution.
So developers don't have to build custom bridges for every single chain pair, which can be risky.
Precisely. So the SDK plus this interchain stuff lets you deploy and manage apps across chains, even talking to Web2 systems, trustlessly, without a central bottleneck.
Okay, pillar 1, verifiable computing and the SDK making things easier and connected. Now pillar 2, the zero-knowledge virtual machine, the ZKVM.
Right, so while the SDK supports different proof types, the article really leans into ZKVMs for the vApp vision. Why? Performance.
And they have numbers, right, from actual benchmark.
They do. Pretty compelling numbers, like up to a 95.7% reduction in proof cycles using pre-compilation.
Wow.
And up to 197 times lower overhead compared to just using the EVM.
That's massive.
Plus, big improvements improving throughput up to 30x faster with parallel GPUs. And proof compression getting huge proofs down to maybe 1.5 megabytes.
Which makes putting them on-chain for verification actually feasible and affordable.
Absolutely critical. These numbers suggest ZKVMs can power vApps with the speed and low cost needed for, real-world apps that millions might use. Near instant responses, tiny fees.
And beyond speed, ZKVMs add security guarantees.
Fundamentally, the proof systems ensure soundness. You can't prove something false in completeness. You can always prove something true. Guarantees the execution was right, the prover didn't cheat.
Plus, being open source helps with transparency.
Right. The article basically frames ZKVMs as the optimal solution for hitting that sweet spot of performance, scale, and reliability that vApps are aiming for.
So how do these two pillars, the verifiable computing SDK and the ZKVM, actually fit together in the full architecture? How does a user transaction flow through?
The main goal of the architecture is to seamlessly connect the off-chain execution, where the heavy work happens, with authenticated data storage and the final on-chain settlement.
All while minimizing trust, keeping costs down, and making it feel responsive to the user.
Okay, so a user does something in the vApp. What's first?
The transaction hits a sequencer, it gets validated, put in order, then that ordered data gets posted to a beta availability layer.
So the input data is out there, visible, transparent.
Exactly. Then the actual processing.
A prover takes that input, runs the core app logic off-chain inside a ZKVM, for instance. As it runs, it generates that cryptographic proof.
The proof that the computation was done correctly.
Right. That proof, which is small, gets sent to the settlement layer, usually a blockchain.
And the chain just verifies the proof, not the whole computation again.
That's the magic. Much cheaper, faster. Meanwhile, there's a vApp server kind of coordinating things.
What does it do?
It pulls results together, manages state changes by talking to the data layer, handles communication with the settlement layer for verification, and deals with any cross-chain stuff needed. It's like the traffic controller.
And the final step, recording the outcome.
Yep. The state changes, once verified by the proof on the settlement layer, are recorded on-chain. Transaction finalized, fast, cheap, but with on-chain trust.
You mentioned a data layer earlier, ADS and DB. That authenticated data structure.
Right. The ADS and regular databases store the app's state, results, history off-chain. The ADS uses crypto tricks, like Merkle proofs, to guarantee that off-chain data hasn't been messed with.
So even though it's not on the blockchain, you can prove its integrity.
Exactly. And the article maps this flow to different layers, too.
Right.
An interface layer for user input validation at the start and recording results at the end.
The user-facing part.
Then a persistent layer. That's where the app reads and writes its state data from the ADS-DB, using those Merkle proofs to check integrity.
Making sure the data is correct.
And finally, the execution layer. That's the engine room. Runs the main logic, computes the new state, and generates the trace needed to create the ZK proof.
So by separating these stages, adding checks like proofs and verified data reads, you get a secure, transparent, efficient system.
And this whole architecture is designed to serve that core goal we talked about, bridging Web 2 usability with Web 3's philosophy.
Because those two things have often felt mutually exclusive, right? Fast and easy, or are decentralized and trustless.
Yeah. Web 2 users expect smooth, hidden complexity. Web 3 prioritizes trustlessness, data sovereignty, often sacrificing that slick user experience.
And the article notes other projects tried to fix parts of this, but maybe didn't offer the whole package.
Right. Maybe helped developers a bit, but didn't solve user friction, or vice versa. vApps aim for that holistic solution. For developers, the Rust SDK means building complex, trustworthy apps without being ZK PhDs. Focus on the service, the UX.
And for users, the ZKVM performance means it feels like a Web 2 app. Fast, reliable, the blockchain complexity is invisible.
It just becomes this trustworthy foundation running underneath. And integrating Succinct's verifiable compute with Layer 0's messaging creates that seamless composability.
They call it upgrading Web 2 from the inside out.
Yeah, a practical way to get user-centric decentralization and maybe finally hit mainstream adoption by unifying convenience and trust.
Okay, so the architecture makes sense. But what could you actually build with this? The article gives examples, right?
Yeah, moving beyond theory to potential real-world uses, looking at both Web 2 enhancements and new Web 3 possibilities.
Like in e-commerce.
Imagine running order logic in a ZKVM. ZK proofs guarantee the order conditions, payment, refunds were all handled correctly, trustlessly, could seriously cut fraud, disputes, handle huge volume.
Sounds useful. What about finance?
Verifiable auditing. Run regulatory compliance checks in a ZKVM. Generate proofs that show you followed the rules without revealing the underlying sensitive data. Regulators verify the proof, not the raw data. Cheaper audits, less manipulation risk.
Privacy-preserving AI sounds pretty futuristic.
But important. Run AI computations in a ZKVM. Keep data encrypted or off-chain. ZK proof verifies the computation, helps with GDPR, allows secure collaboration on sensitive data sets.
Media authenticity, too, combating deepfakes.
Yeah, using vApps with standards like C2PA metadata, ZK proofs could guarantee that metadata hasn't been tampered with as content moves around, adds a strong layer of verification.
Okay, shift into Web3 native stuff. DeFi.
Privacy-enhanced DeFi. ZK vApps using ZK proofs to validate swaps or transfers but keep amounts or identities confidential.
Makes sense. Web3 gaming. Fairness is a big issue there.
Totally. Run game logic, random numbers, state updates in a ZK VM. Put proofs on chain so players know it was fair. Solves the trust issue with off-chain game servers but keeps it fast.
DAO treasuries. Managing funds transparently.
Right. Check proposal conditions off-chain in a vApp. Use a ZK proof on-chain to verify funds were released exactly according to the rules. More transparent, more accountable.
Verifiable credentials, like digital IDs.
Enhance DI dilets. Store credentials. Use a vApp for selective disclosure. Prove you're over 18 without showing your birthday, generating proofs of validity and consent.
And stablecoins, proving reserves.
Use a vApp to analyze reserve data off-chain according to set rules. Convert results into ZK proofs for the public or regulators. Real-time, verifiable audits. Builds trust.
Those are great examples, but is anything actually built on this yet?
Yes. The article specifically highlights Paygo as the first real application using this vApp architecture.
Paygo. What is it?
A stablecoin payment system. Key features. Fixed fees, scalable, and user protection via ZK proofs. It allows things like asset protection, trustless remittance, escrow, all without a central operator managing the logic.
So it's concrete proof. This isn't just theory.
Exactly. It shows vApps are a tangible reality being built now.
So wrapping up, where does the article leave us looking ahead?
It loops back to the start. The real bottleneck isn't just raw blockchain speed. It's the lack of tools, the middleware, for developers to easily build and compose complex things. vApps aim to be that enabling layer.
By focusing on composability, abstraction, modularity, simplifying development towards Web2 standards.
Letting teams focus on the actual service, the user experience. A new approach to developer culture, they say.
But they also acknowledge remaining challenges.
Oh, for sure. Getting broad adoption across the ecosystem, deep connections between chains and apps, that's a big one.
And the cost of generating ZK proofs, even with faster ZK VMs and hardware. Stereo factor at massive scale.
Could be, yeah. Hardware costs, parallel computation needs, and crucially, designing the right economic incentives and governance for the decentralized players, sequencers, provers, servers, so the whole system stays reliable and sustainable.
So hurdles remain.
Definitely. But the conclusion is that vApps offer this practical foundation. Building apps that look like Web 2 but run on Web 3, how well they overcome those hurdles. That's the story to watch.
Okay, so let's try and summarize the core takeaway here. vApps, driven by verifiable computing, especially these powerful ZK VMs, seem to offer a really promising way to finally get Web3's decentralization working with Web 2's user experience and scale.
Yeah, they tackle those big barriers, user friction, developer complexity, by creating this unified environment and hiding the trustless execution layer from the user.
Which leaves us, and you, the listener, with a final thought perhaps. We see the performance potential of ZK VMs. We see the promise of a smoother developer experience with the vApp SDK. Will that be enough to overcome the remaining hurdles? The ecosystem adoption, getting the incentives right, managing proof costs at scale.
And if those hurdles are overcome, could vApps truly be the key that unlocks mainstream Web3? What might that look like for the apps you use every day? Something to think about.